So what I've done this time, similar to what we did for the last time there, is I've turned it into a clicker thing. So actually, let's get the clickers right now. So what I've done is I've given you a photocopy of the relevant pages from that textbook. So rather than sort of try to guess, you can, here's the first question that's on the screen. You've got it on your sheet as well. So here's the first question. All energy in all ecosystems begins with, and now you can find it in the textbook reading. I'll just hit start. So those are the three things that the sun does. It lights and warms the earth, so that's light and heat energy. Evaporates the water, that's a form of heat. Provides energy to plants. So how do we get energy from coal or gas? Like we watched a couple of videos the last couple of days about getting energy. There was nuclear energy. But like, how do we get electricity? In Canada, we don't tend to get a lot of electricity from coal or gas, but in the United States they do. How do they do it?
They burn it.
They burn it, which heats water, which generates steam, which turns turbines and generates electricity.
That's the same, basically the same just as hydrogen.
Yeah, pretty much. Well, how does hydro generate electricity, Charles?
Like the town, because there's a big, like it's like a wheel.
Turbine. Yeah. Right? So the water is dammed up, and it's allowed to go through a smaller opening, turns the turbine like a fan, the reverse of a fan, right? Like really, a turbine is the opposite of a fan. The fan gets electricity, turns it, a turbine gets turned, generates electricity, right?
Hydro's supposed to like double their rates for like the next like 5 years.
There has been some discussion in the news about hydro's rates going up. They've asked for a 7%, I believe, increase.
It's because they spent all their money on the dam up north.
And whether or not that the dam is useful or not is debatable, right? Yeah.
And it's not really for us because they're exporting it anyway.
Yes. Now, having said that, you would think that other places would prefer to import Manitoba Hydro because it's clean energy. Like, is hydroelectricity, water generated electricity, is it cleaner than coal and gas? Certainly. Is there some ecological effects to using hydro? Yeah. So, like when they dam up a river, what are they creating? A flood, really, right? So they are flooding a floodplain, which damages that ecosystem there. But long term, once that's done, it's done, right? Like it's not sort of continuing to add more pollution or anything like that. Okay. So yes, AJ's right. We burn the coal or gas. So how does the energy get then from the sun into the coal? Like if you burn coal, you get energy, but how does it? If it ultimately all goes back to the sun, all energy in all ecosystems begins with the sun. How do we get energy in coal or gas? How does it get there? It's a long-term process. Say again here? From the ground? Well, what is coal?
It's a mineral.
It's a fossil fuel. What does that mean?
It's broken down.
Yeah, it's a fossil. So coal is simply plants, partly animals, that have died, decomposed over the years, right? And under the pressure of the earth, they form coal. So the energy that those plants once absorbed millions of years ago from the sun is still in there. It's still locked in its molecules, exactly, right? So it's carbon, right? Same thing with gas. Gas and coal are simply fossil fuels that were once probably plants that have been converted to another type of carbon. Exactly. Okay. So here's the next question. What is the process called that plants use to take solar energy and create food? What is the process called that plants use to take their solar energy and create food? Oh, I thought we were all going to get it. The answer is B. Is it not?
Yeah.
Photosynthesis. Right? They take solar energy and they create food out of that. They create glucose, carbon. Are you guys finding the answers in the reading? Or you just knew that one? Okay, this one you're going to have to look up, I think. This one you're going to have to look up. Of all the energy that is released by the sun, how much actually reaches the Earth? Now, this was actually in the video the other day too, right? Solar energy one? So what do you think it is? 100%, about half, about a quarter, about 1/billionth?
Doesn't really say on here.
No. Okay, so what happens to all that energy? Like, here's the sun. Oh.
Is that why you have that volume?
Well, it's awesome for talking and stuff. I've used it many times.
It is actually.
Right? So all of the sun's energy that radiates out, like, where's the Earth? Way over there, Rubens. Either like hold up your pencil tip there, like pointing your. Yeah, no, the other end, like tiny. Yeah. Okay. So how much of this light is going to reach Rubens' pencil tip?
Not a lot.
Not a whole lot. Like there's all that light going all that way and
That's
that way.
what you mean by that question.
Right? Like how much of the sun's energy actually hits the Earth? And the answer is about 1/billionth.
1 billion is pretty small. Though.
Incredibly small.
Oh.
Point zero 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 zero
It
zero zero.
was like 1 billion was like.
No, 1/billionth, like one, not 1/2, 1/4, like tiny, tiny, tiny.
Earth, the Earth's starting to get a little chilly. Just put a big mirror up.
Yeah, big, like one of those solar cookers.
Yeah.
I've always wanted to build one of those solar cookers, cook hot dogs. Yeah. How much energy then does the Earth receive from the sun? Well, here's the answer. At any moment, I think you guys have to do a little fill in the blanks here in your sheet. At any moment, the sun emits about 3.86 times 10 to the 26 watts of energy. Okay? So what's, and I love saying this, what's a watt? Well, it's a unit of power, really, energy. When you put in a 100-watt light bulb at home, 100-watt light bulb is pretty bright, isn't it?
Yeah.
Right? So that's 100 watts. So the sun emits about 3.86 times 10 to the 26 watts. Imagine that much brighter than a 100-watt light bulb. Okay? And 3.86 times 10 to the 26 is this number here. Right? So it's 386 and then 24 zeros. 386 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many watts?
How much money?
That's a lot of light bulbs. It's a lot.
So you had 24 zeros on there?
Yeah. Oh, there it is there. Did you fill something in? Wouldn't it be nice if we could use that energy? I mean, I guess you could argue we are. When we're burning coal and stuff, we are using that energy. We're just using the energy that was solar energy from 1 million years ago. Right? But we're creating issues with our climate.
You have to stop those up for your big segment and do whatever you want.
Yeah, but you wouldn't know it until it got here. So
Sure.
I think it's 8 minutes for the sun's
Oh,
energy. Yeah.
There's 8 something.
Yeah. Most of that energy goes off into space, but about 1.74 times 10 to the 17 watts actually strikes the Earth. Or 174, that big number there, right? So that's still a lot of energy that strikes the Earth. A lot of energy. If there's no clouds in the way, 1 square meter of the Earth will receive about 1 kilowatt of that energy. So think about 1 square meter, that's like 9 tiles. Like if you stood like this, right? If 2 people stood like this, that much and a meter apart, right? That much space. It's not a whole lot. 1 kilowatt of energy. So for the 6 hours in the middle of a sunny day, an area the size of a small backyard pool, about 48 square meters, will receive about 288 kilowatts of energy. That's nearly 10 times what the average U.S. household uses in the entire day. In only 6 hours. 6 hours of solid sunlight can produce enough electricity to power 10 households in a day. We saw the video 2 days ago, or did I show it to you? No, I didn't, did I? I didn't show it. Oh, it's coming at the end. That's right. I got a video at the end about solar power. 'Cause we didn't, or did we watch it yesterday? Did we watch one on solar power yesterday? No. Okay. So why don't we use more solar energy and less coal? Like, is the solar energy free? Well, it's not free to harness it. The actual energy itself is free, right? Like, you don't have to pay anyone for it. It's just coming from the sun. The sun's giving it away, right? There's certainly a cost to harnessing it. You got to build the panels. You got to pay the people to maintain the panels. You know, you got to distribute it, kind of thing. Why don't we use more solar energy and less coal and gas energy? Well, first of all, when was coal and gas energy first sort of invented or developed? Yeah, like probably I mean, they've been burning coal a long time. Right? People have been burning coal a long time. People have been burning wood a long time, right? Certainly, scientists realized that the sun had energy. There's a Mythbusters episode where there's an old myth about I think it was a Greek warrior had an invading army, and they defended their city by using giant mirrors, and they all focused their mirrors on the ships of the invading army, and they burst into flames. Now, is that possible, do you think? No. The Mythbusters did. It's pretty much impossible. But it was certainly blinding to them, right?
We should watch that.
Yeah, I should find that one.
You do it now?
It does sound pretty
I'll get to it. It is kind of interesting.
We should put it to
If we could burn something like that with mirrors.
Actually,
I know you
Well,
can.
if you put one of those new flashlights and then get 5 pieces of glass, and if you do that, and you put it on a piece of paper, it actually works.
Oh yeah,
I've done that.
magnifying glass. Basically, magnifying glass is taking that much solar energy and just focusing it, right? Yeah.
I started on there.
Okay. So, well, one of the reasons that we don't use, I guess we should answer this here. Why don't we use more solar energy? Well, we have a network already for coal and gas. Like, we've already invested a lot of money in mines and pipelines, right? Distribution systems. So people don't want to give that up, right? There's jobs invested. People have invested a lot of their life in these systems, right? So there's a network already for coal and gas, and it's not quite as efficient. They're working at it, right? The new solar cells are becoming more and more efficient. Did anyone go to the trade fair a couple weeks ago? There was like a solar display. I would have liked to have gone and talk about it. But the solar cells are becoming way more efficient, right? Solar cell in a calculator. How efficient is it?
Well, it's not.
It doesn't really need to be. How much energy does a little calculator take? No, doesn't need that. Like, even in this lake, there's enough to power one of these, right? But if you're going to be powering a house, right, you're going to be producing enough energy to drive a car or a truck, you need a lot of energy. You need big, bulky solar panels. Have you ever seen any of those solar cars? Let's talk about the albedo effect. It's in your handout there. Albedo refers to a person with no skin color or pigmentation, a African water mammal, a measure of the amount of light that is reflected, or a measure of the amount of light that is absorbed. Albedo. Oh, I didn't stop the last one, apparently. How'd you guys do here? Oh, yeah, go ahead. Albedo.
You made it so I could change my answer?
Yeah.
Not in the middle, no. You can't go delete and change it?
I don't think so.
I have no idea what this one is.
I just read more and I got the
Yeah, I know you can change your answers, but I don't know on these single question ones. I know I can't edit while we're doing it. It'll be okay, Brad. What's the right answer? The answer is C.
Oh.
Who said a person with no skin color or pigmentation? What's that called? Yeah, that's an albino. The correct answer was C, a measure of the amount of light that is reflected. So albedo is like how much reflection you got off it. What would be an example of something that has a really high albedo? The higher the albedo number, the more light it reflects, the less light it reflects, or the same amount? The higher the albedo, the more light it reflects? The less light it reflects, the same amount. Got it, Charles? And the answer is A. The more light it reflects. The bigger the number, the more it reflects. High albedo, high number. More light it reflects. So which of these would have the highest albedo? Fresh snow, asphalt, shingles, grass. Which would have the highest albedo?
Gosh.
Remember, albedo is a measure of how much light it reflects.
Reflects. So like,
Higher the albedo number, the more light it reflects. Which one would have the highest albedo?
oh, hold on. I'm probably wrong.
Well, you got a 1 in 4 chance of getting it right. I don't think this is in the reading. You're going to have to actually think. The answer is A. Fresh snow is extremely bright. When you go out in the wintertime and there's fresh snow and the sun is out, it's really bright. You got to wear sunglasses, right? The Inuit have those very they take the bone and they put the very tiny hole in it, right? They wear those so they don't go snow. You can go snowblind because there's so much light being reflected back at you. But you can go blind by being out in the snow on a sunny day.
Maybe that's not bad at seeing things.
What do you mean?
Doing a lot without a helmet.
Oh, yes. You often see like the guys climbing Mount Everest, the people, right? You see them wearing the goggles. Which would have the lowest albedo then? Fresh snow, concrete, blacks, shingles, or grass? Lowest albedo.
Oh,
And the answer is C. Black shingles have the lowest albedo. They don't reflect at all, right? What do they do with all that sunlight? They absorb it, and that's why they get really hot. If you look underneath shingles, there's a little bit of tar underneath. Why did they put that there? The shingles heat up, the tar melts, and it sticks to the one below, right? Ukrainian dancers up at Country Fest at the CNUF, they will actually burn their feet before they had the roof on, right? So someone would come down, black mats, and they would actually go out, step on those mats, and they would burn their feet right through their boots. That's how hot it was. Kind of thing. If you go to Cancun, anybody been to Cancun? Cancun has, their beach is not made of, most beaches are made of sand. Their beach is made of tiny particles of coral, which is very white. It's extremely bright. You have to wear sunglasses. Extremely bright, but you can walk on the sand because it's very cool. How come? Because all the light is reflected, right? So the light that's reflected can hurt your eyes, but safe for your feet. Whereas most sand, right, if you walk on it, can be quite hot.
Really hot.
Exactly, right? Because it's absorbing.
hot, cold.
Yeah. Yeah. Okay, so
In Saskatchewan.
the snow in the winter contributes to the low temperature because it reflects a lot of heat back to space. Is this true or is this false? The snow in the winter contributes to the low temperature because it reflects a lot of heat back to space.
Oh, maybe.
Well, I'm asking, what do you think? Is it in the reading?
No idea.
Correct answer is true. The snow does contribute to low temperature because it reflects a lot of heat back to space, right? You ever notice in the springtime, right, when the snow is melting, what's one way you can make the snow melt faster? You could spread some dirt on it, right? Yeah, or have you noticed how like the snowbank will melt? Where does it melt? Near the edges. How come? Because the ground's absorbing the heat and it's keeping that heat there, right? You'll see some people taking their snowbanks and spreading it around. Why does spreading it around work? Because you're allowing some of that dark splashes around to absorb that energy and melt it. Yeah, I'm having trouble with words today. Okay. So if you look on your page, okay, so you have this as well, and you also have. So this is like question number 4, right? On the back side of your handout, right? Table number 1 provides data collected following the eruption of 4 volcanoes. The average summer temperature decline following each eruption. So after each one of these volcanoes, Mount Asama in 1783, there was a 6-7 year period of low temperature. Mount Tambora, 1815, a 4-year period of low temperature. Mount Krakatoa, and so on. Mount St. Helens. I remember as a kid in 1980. Anyone know where Mount St. Helens is? It's in the United States, that's right. It's in Washington State. So like just think south of Vancouver. I remember Mount St. Helens erupting and the next day going to school, elementary school, and everywhere it was covered in ash. So like we're talking thousands of miles away. There was a very thin layer of dust on everything. Cars, buildings, the road, everything. Kids with asthma couldn't breathe. We really couldn't go outside for a day or two. There was so much ash in the air. It was crazy. So why do you think volcanic eruptions cause periods of low temperatures? So what does that mean, AJ? You're right, but what does it do?
It's either reflecting the light or it's absorbing it. Well, I'm guessing it'd be reflecting the light off someone.
So imagine all this ash in the air, right? Sunlight comes down on the earth, right? Sunlight comes down on the earth, and there's all this ash in the air, like clouds, where it hits that ash and it bounces back, right? So yes, it creates long periods of low temperature. So why do you think? So what kind of answer should we put there?
Because the ash is more reflective than the stuff.
Okay. How about something like ash in the air reflects back a lot of energy. Does that work? Ash in the air reflects back a lot of energy. How can we test that? Like small scale in a lab. How could the Mythbusters test it?
Flashlight here.
What kind of paper? Black paper. What if you had like, okay, so
Or a light bulb.
what if you had a flashlight, a powerful flashlight, I guess, right? I'm not sure how to draw this, right? And it's shining light off, right? And what if you had like a solar panel here, and it's hooked up, the solar panel is hooked up to like some sort of device that measures how much electricity is created, right? So you got a flashlight, you got a solar panel, and it's
I have
hooked.
a huge flashlight.
Yeah.
Big spotlight. It'll shine like 50 miles probably.
Really?
Yeah.
50 miles is a long way now.
It'll shine.
But what if you could measure how much energy was being created by that solar panel, and then you took like, what could you put in the air to simulate ash? I guess you could go get like ash from a fireplace or something other, right? What if you could somehow, I guess you'd have to shine it through like a clear box or something other, and then you filled that up
Glitter.
with ash or something like that, right? And then you measured. Would that work? I think that something like that would work, right? Like it would tell you what the difference is. So something like that. Can you write that up, what I just drew?
That is true.
Okay.
Is that okay?
Yeah, I guess.
Oh, yeah.
Which one of those eruptions do you think was the largest eruption? And how could you tell? Or why do you think it's true?
The first one, because it was the longest period.
Yeah, because this one is 7 years, this one's only 4, this one's 6, that one's only 1 year, right? I would agree. So in 1783, there was a huge eruption that created probably worldwide period of low temperature. The ash was in the air that long. This is Mount St. Helens. I had a hard time finding a map. I could only find one that showed the United States, and here's a North American one here, right? So Mount St. Helens is out here, right? And Manitoba, we are about located right there, right? So if you take that and you sort of extrapolate it into Canada, right? I grew up in Neepawa just down the road, so within the zone, right? So you can imagine how much ash. So that says like trace to a half an inch. So up to a half an inch of ash. And I remember that day. Here they show it here. But I know for a fact that we had some.
All that ash in the air, and it lays down on things. Where does all the ash go eventually? Because it's not like you see it anymore.
Well, that's true. I mean, it does get swept up. It probably gets swept up and turned into dirt, soil, right? Like, I mean, it's organic matter. So, would you like to see Mount St. Helens eruption?